Big Data and Hadoop training, the first free session. So guys, let's see the agenda for this session. We will start with introduction to big data. We'll talk about various aspects of big data here. Then we'll talk about the conventional approaches and problems associated with it. The solution of big data, that is Hadoop. We'll talk about HDFS and MapReduce, the core components of Hadoop. Then we will discuss Hadoop use cases and its ecosystem. We'll talk about the future of Hadoop and big data, career in Hadoop and big data. And then we'll talk about Hadoop and big data expert course by DataFlair. So guys, for today's session, your questions will be taken at the end. Please hold your question just for today's session. In our regular sessions, your questions will be taken immediately. And apart from this, today you are kept on mute. Due to large number of audience, you are kept on mute. So in actual session, you can speak similar to me. Let's proceed ahead. About DataFlair web services. So guys, we are a big data startup where our mission is to provide big data solutions to the business. We are helping several organizations to solve their big data problems. We also provide training on cutting edge technologies, the technologies which are launched recently, like Big Data Hadoop, HBase, Kafka, Storm, Spark, Cassandra, few BI technologies as well, SAP BI, SAP HANA, Jaspersoft, Microsoft BI, etc. Guys, a little bit about me. So I have spent guys more than 17 years in the industry. I have started my career long ago in Unix, and I switched my technology as well as domain multiple times. So over last almost 5.5 years, I am working in big data. So prior to DataFlair, I was heading the big data practices in a leading analytics firm. Here in the DataFlair, I am one of the co-founder. So guys, I'll be your host for the complete training. Regarding my education, guys, I have done my BTech from IITB and MS from BITS. Big data, the biggest buzzword. Guys, big data is the biggest buzzword in the industry. What leaders say about big data? According to IBM, let's read one by one. According to IBM, big data is not just a technology. It's a business strategy for capitalizing on information resources. According to Gartner, big data is the new oil. Guys, we are aware that oil is the most valuable thing on the planet. And according to Gartner, big data is the new oil. According to Experfy, Hadoop market will grow at CAGR, that is compound annual growth rate of 58%, and it will reach $50 billion by 2020. So Gartner says big data will create over 4 million jobs by 2015. One more big line from the industry leader GE. Big data is the future of industry. Big data is the future of IT industry. According to IDC, big data market will be growing 6 times faster than overall IT market. Guys, just compare with the overall IT market, 6 times fast. According to McKinsey, the US alone faces a shortage of 1.5 million big data professionals. So IBM's this bold definition I'll read at the end. One more statement from IBM. Big data is the biggest buzzword because technology makes it possible. Because technology makes it possible to analyze all available data. Guys, one of pretty big statement from IBM. Big data is not just a technology. Big data is not just a technology, it's a paradigm shift. Like guys, we were working on RDBMS, the legacy systems, for last 2 decades, more than 2 decades. These technologies was matured in 90s and even late 80s, and we were using this for quite long. But these old technologies are now not capable to solve our new problems. So in late 80s, we shifted from older technologies, the local file system, to RDBMS. That was a paradigm shift. Now industry is having another paradigm shift. That is, we are shifting from older technologies, legacy systems, to big data technologies. Let's talk about what happens in a minute. What happens in a minute? Little interesting facts. What happens in a minute? 200 million emails are sent just in a minute. 4 million search queries on Google. 2.5 million pieces of contents are shared on Facebook. 72 hours of new videos are uploaded on YouTube just in a minute. All these figures, facts are of just a minute. $80,000 online sales generated by Amazon. 220,000 new photos are posted on Instagram. 300,000 tweets posted by Twitter users. 50,000 apps are downloaded by Apple users. Guys, these all facts are just, these all happens just in a minute. Let's proceed ahead. Introduction to big data. Now guys, let's understand big data. What exactly is big data? Big data is all about finding the needle of value. What exactly is big data? We want to find out the needle of value. We want to find out the insights. We want to find out the intelligence. We want to find out the exact value out of my data. So guys, a very basic definition about big data, although in subsequent slides we will be having a few different definitions from industry leaders. So big data is all about finding the needle of values in haystack of structured, semi-structured and unstructured information. Can anyone tell me what is structured data, what is semi-structured data, and what is unstructured data? Correct. Semi-structured data is in the forms of XMLs or JSONs. What about structured? Yes, structured data can be stored in RDBMS. Guys, structured data is simply like in the form of rows and columns. One more answer. Semi-structured data can be pre-processed and converted into structured format. What about unstructured data? Okay, images, videos, audios. So guys, if I tell something more about unstructured data, the data which I can't store in RDBMS, I can say unstructured, like machine logs, like your multimedia, like the text para, documents, emails, meter collected data, sensor data. All these are unstructured data. So guys, big data is all about finding the intelligence out of all the types of data. Guys, why big data is booming currently in the industry? Because we want to find out the intelligence. We want to help the business in taking the decision. Big data helps the business in taking right decision at right point of time. Let's proceed ahead. So guys, few more definitions of big data. Big data we understand quite easily as in the terms of volumes. Like I am having 10 petabytes of data. I am having 1000 terabytes of data. I am having 100 petabytes of data. That is a big data. Yeah, agree. Totally agree. But guys, this is just a single volume of big data. Gartner defines big data as high volume, high velocity, and high variety of information assets. Volume we understand quite easily. That is huge data. What about velocity? Guys, velocity means the speed at which data is generated. But I would say this is a half definition. Why? Because guys, the complete definition is the speed at which data is generated as well as the speed at which the data is processed. Both speed must match. Both these speeds must match to meet the demands. So in next few slides we'll discuss about all these V's, that is volume, velocity, variety and veracity. Variety, just one liner definition right now guys, like different varieties of data. Like you are having data from Facebook in totally different format, data from YouTube in totally different format, data from blogs again in different format. So different varieties of data. So guys, if I again repeat this definition, according to Gartner, big data is high volume, high velocity and high variety information assets that demand cost effective as well as innovative form of information processing. Guys, We need a solution. We need a cost-effective solution. Because guys, if you recall to about our legacy systems like RDBMS, to handle the small volumes, the cost was very high there. So you can imagine for high volumes how much cost will be there. So that's why in the first definition only, we want a solution with the cost effective nature for enhanced insights and decision making. Guys, again we reached to the same conclusion. For enhanced insights, because we want to analyze the data, we want to capture the data and generate the insights. What exactly are there inside the data? We want to discover undiscovered patterns out of my data and help the business in taking the right decision. Guys, I think it would be little late. Then also let's take one use case. Like earlier, before big data came into picture, earlier the analysis was like historical analysis. Like usually business asks, what was my sales? What was my sales last 6 months, last Diwali, last any festive season, or last 5 years? And IT answers these questions like they generate the trends, reports and all. But can they take any decision out of this historical reports? No. Now the analytics is touching new heights. Today business asks the questions about future. What business asks? What will be my sales this festive season? Tell me about my sales. What will happen? So guys, that is predictive analysis. Business is now more interested in knowing what will happen. So guys, today with the help of big data, we can answer the questions about the future, that we can tell during this festive season or in next this 2 months or next Diwali, this will be the sales of these products. We can give them the reports. We can predict the future with an accuracy of around 80%. Now guys, just imagine if we can tell that boss, this will happen. We can let the management know that this will happen with an accuracy of 80%. Business can take all the decisions. Like they can make the required PO, they can arrange all the required items, and even they can promote the other items whose sales we marked as low. We are helping with the help of big data. We can help business in taking the decision. So in use case section, we'll discuss this thing in little more details. One more definition from IBM. Guys, according to IBM, 80% of data captured today is unstructured. Now guys, one question. Can RDBMS handle unstructured data? Can RDBMS handle unstructured data? No. RDBMS can't handle unstructured data. So guys, till now we were simply dumping off these unstructured data. We didn't have any mechanism to handle this 80% of data. And we know data is the gold mine. Whether that is structured or unstructured, there are gold mines of information in the data. But we were not capable with the legacy systems. We can't process these unstructured data. So guys, these unstructured data generated from sensors used to gather the climate information. So guys, we are aware that earlier we didn't predict that what about the cyclones, natural calamities. Let me take one example. Earlier what was happening that once the cyclone hit us, like tsunami hit us, then we came to know, oh, this natural calamity happened and at this place, and now the government will take the necessary action, and there is a huge loss of man and money. But with the help of big data, we can predict, we can tell that. Let me take the real example. Even we are aware about Hudhud. Government knew in well advance that Hudhud will attack Visakhapatnam at this location at this time. Government took the necessary preventive measures in well advance. Isn't it biggest gift from big data to mankind? So guys, few other sources of unstructured data are like posts to social media sites, digital pictures and videos, your purchase transaction records. When you go to mall and you purchase anything, that is on POS, point of sale, the data is not generated in structured format, it is generated in XML format, and volumes are very high. Apart from that, like cell phone GPS signals and so on. So guys, all of these unstructured data is also big data. Guys, I'm getting few questions. Guys, please hold your questions just for today's session. We'll discuss all your questions towards the end of the session. Evolution of big data. Now guys, if we talk about history, data was incepted in late 60s or early 70s. It was very early days. It was a pre-relational era. At that time, just a very small amount of data was generated. Data was primitive and structured. And mainframes were the basic data storage. Then we understood the data requirements. We understood that yes, data is quite important. Like at that time we were understanding that I need to maintain my historical data, that what exactly is happening with me about my business and all. So 1980s, from 80s the relational era came, that is RDBMS. N number of RDBMS came into the industry, like Oracle, like DB2, MySQL, MS and so on. The data was quite complex. There was complex relationship in the data. Like we normalize the data, we create referential keys. And that era was like data utilization. That was like we were able to answer the few questions like what was happened, what was my sales figures, my different analysis. We were able to do. So these RDBMS were very good technologies. These are very matured and very good, but they can't handle volumes. So guys, from 2005 approximately, although Google got the big data problem in early 2000s only, Yahoo was also facing the same issues. But in 2005 onwards, the complete industry, whether that is financial, whether that is telecom, whether that is retail, the complete industry started facing the issues of big data because of exponential growth of data. My data is growing and growing. With the introduction of internet, with the introduction of social media, e-commerce, tons of sources came into the picture. Guys, business, all the industries are very interested in processing the social media data as well, processing the data from all the sources, because all these data is also having tons of information. So this particular era is data driven, where we have varieties of data, that is from structured to unstructured, multimedia, machine, different types of data. So this is the current era from 2005 onwards in which we entered, and around 2012 almost all the companies have started working in big data. In early days Yahoo entered, in early days Facebook entered, Twitter entered, Walmart entered. These are the early entrants. So guys, if we talk about data explosion, currently there is a data explosion. You will be surprised to hear every day we create 2.5 quintillion bytes of data. Every day 2.5 quintillion bytes means 2.3 trillion GBs. $2.3 trillion GB of data every day. Isn't that huge? Guys, so much that 90% of the data in the world has been created in just last 2 years. From 60s to 2013, guys, just understand, from 60s to 2013, whatever data is generated is contributing merely 10%. And from 2013 to 15, the data generated is contributing 90%. You can understand the data generation curve is pretty much exponential. It is pretty much exponential with time. So guys, in late 90s it was predicted from the industry experts that with time my data will grow linearly. So they were expecting that data will reach this location. This much volume will be there with time. But actual volume is far above. So guys, the lower one is our ability to do something with the legacy system, and upper one is the actual volumes. That is the big data. So guys, there is a big gap between our ability to do something with the data using legacy systems and actual volumes. That is big data. So guys, if we take a few examples from the industry, especially industry leaders, Walmart, the giant in the retail industry. Walmart is having 200 million weekly customers across 10,700 stores in 27 countries. Guys, Walmart is having 1.5 million customer transactions every hour. That's huge. 1.5 million customer transactions every hour, which generates 3 petabytes of transactions data in its Hadoop cluster, which add 3 petabytes of data. So guys, you can imagine the volumes that Walmart is having. If we talk about Facebook, so guys, Facebook, the most popular social media channel, everybody uses Facebook. It is having 4.5 billion Facebook likes every day. 350 million photos are uploaded on daily basis. That's huge. I'm sure many of you are aware that, guys, profile pic of users are getting loaded quite fastly as compared to the images he has shared. The reason is your profile images, your profile pictures are stored in Hadoop and its ecosystem, which gives the result, the name of the technology is HBase, the ecosystem component of Hadoop, which gives the result in the range of sub-seconds. Even when you have data in the range of thousands of petabytes, where if we suppose to put our legacy system, if we suppose, although legacy system can't handle that much data, so your RDBMS will be needing months to give you the result, and HBase is giving you the results in sub-second, just like 1 millisecond, 0.1 milliseconds, like 250 billion photos are stored by Facebook. Guys, 10 billion messages are sent every day, and even the chatting and messaging system on Facebook is also on the top of Hadoop and its ecosystem, that is Hadoop, Hive and HBase. 1 trillion posts are there in Facebook's graph search database. There are 1 trillion posts. That's really huge. Facebook is having huge volumes with it. Let's proceed ahead. So guys, this particular infographic is from IBM. It was a join from McKinsey, Twitter, IBM and all. So here we will talk about different dimensions about big data. Is big data just about volume? No. There are several different dimensions in the big data. Let's talk about all these dimensions one by one. The very first dimension, volume. Volume means scale of data. Volume means scale of data. Guys, there will be 40 zettabytes of data. There will be 40 zettabytes of data on the planet by 2020. 40 zettabytes means 43 trillion GBs. Volume is quite easy dimension, we understand that, yeah, huge volumes. Just one more figure. Most of the companies in US have at least 100 terabytes of data stored. Most of the companies. Let's talk about the next dimension. Volumes we understand, yeah. So these volumes can't be handled with the legacy system. We can understand that easily. The next dimension, that is velocity. Next dimension, that is velocity. Guys, velocity means speed at which the data is generated as well as the speed at which data is consumed. My consumption speed, my processing speed must be equals to or greater than generation speed. If it is less than the generation speed, I am not in the picture, I am not in the race. I can't really handle the big data. Because guys, huge volumes are generated with high velocity. Let's take one example. The New York Stock Exchange captures 1 terabyte of trade information It captures 1 terabyte of trade information during each trading session. One terabytes. You can understand, guys, there are billions of transactions. For each and every transaction, since this is a financial transaction, tons of checks are done, like tons of validations are done, like fraud analysis, whether the requested transaction is fraudulent or not. Okay, let me take a little simpler case. I'm sure, guys, all of you are using credit card. Billions of, if not millions, billions of credit card transactions happens every minute. Now, guys, it's a very big issue to identify the potential fraud, whether the requested transaction is fraudulent or not. Suppose you are giving your credentials, you supplied your password. Now, firstly let me ask, how much time does it take to do a transaction? Once you supply your credential, once you supply your password, how much time does it take for the transaction? Correct. Hardly few seconds, 2 seconds, 3 seconds, not more than that. We can't wait really. Extreme 5 seconds. Correct. 5 seconds, like during this particular time, firstly you will be authenticated with your credential, that whether your password is correct or not, your PIN is correct or not. Then your data will be sent to analytics system. Guys, understand this, very important. Your data will be sent to analytics system where transactions will be analyzed. What exactly analysis? Just let's take example of fraud detection, whether the requested transaction is fraudulent or not. If I give you one example, say at 9 a.m. I am doing a transaction from Mumbai, and just after 2 minutes there is a transaction request from same credit card. There is a transaction request from Chennai. This second transaction must be stopped. There is something wrong. Okay, if we discuss few more cases, like usually you do transactions in INR, suddenly a request in USDs. Usually you use the card from India, suddenly a request from UK. These transactions must be handled carefully. So guys, in the analytics system we are having merely few seconds, or even I should say few milliseconds we are having, because the data firstly travel to transaction systems where it is authenticated, and now in the analytics system. Now you need to analyze streaming data. While data is flowing, you need to analyze that data. That's data in motion analytics, very new term in the industry, data in motion analytics. While your data is traveling, analyze that data. Velocity is quite interesting dimension, and especially when velocity and volumes are clubbed together, that is, you are getting huge volumes with high velocity. So that's a brief about velocity. Let's proceed to variety. So guys, variety we can understand quite easily. It's a different form of data. Like if we take few examples from this slide, as of 2011, the global size of data in healthcare was estimated to be 150 exabytes. Just in healthcare in 2011, the size of the data is 161 billion GBs. That's really huge. If we take another example, 30 billion pieces of contents are shared on Facebook. 30 billion pieces every month. Few more examples. 400 million tweets are sent per day. 400 million tweets by around 200 million monthly active users. 4 billion plus hours of videos are watched on YouTube each month. More than 4 billion hours. That's really huge. So guys, there are huge volumes from n number of different sources. I'm getting volumes in different varieties. I'm getting volume in different varieties. So variety, we can understand tons of forms of data, whether that is a normal text, whether that is image, video, audio, healthcare data, Twitter data, and so on, XMLs and so on. Let's proceed ahead. Veracity. So guys, veracity is a little different, little challenging dimension. It refers to uncertainty in the data. The data which we are collecting may have ambiguities. The data that we are collecting may have noise, abnormalities. Because guys, the data is traveling from one location to another location, there are chances of data loss, data ambiguities, noise. So guys, due to which 33% business leader don't trust the information that they use to make the decision. Your data must be cleaned. Your data must be pre-processed before entering into the data center. Poor data quality cost US economy around $3.1 trillion per year. That's really huge. Just a small information. By 2015, 4.4 million IT jobs will be created globally to support big data, with 1.9 million in United States. So thus particular things we will discuss in future and career in big data later section. Let's proceed ahead. Now guys, let's quickly talk about the problems with the conventional approaches. What exactly are the problems we are facing for quite long? You can also relate your own use cases, your problems. Limited storage capacity. Guys, our legacy systems are deployed on single machine, and on a single machine I can store certain limits. I can store certain limits of data. I can store data within certain limits. So like take the example of Oracle. I can't store petabytes of data in Oracle which is generated today. So we are facing the issue of limited storage capacity. Now guys, what happens that when your repository is full? As soon as let me give you one example. A leading telecom operator need to archive its data again and again. They can handle very limited volumes of data. They can handle just last 1 year's data, and they need to archive their data again and again. And guys, archival of data is a data death. We are killing that. Data archival is a data death. This is the worst thing that we can do. In the modern systems, in the big data systems, we do not archive our data. Big data provides you infinitely scalable storage where you don't need to archive your data. But guys, with the legacy systems, we need to archive our data. And the worst thing that my client was facing, the worst issue that my client was facing from their business, they keep getting the requirements. They keep getting the requirements they keep getting the requirements of reports of the data which is already archived. Now guys, you can understand that archived data will be again loaded into another system for the reporting purpose, and this particular procedure take around 48 to 72 hours. Limited processing capacity. Again, since your repository is on single machine, you are having limited processing cores. You are having limited processors available. Like guys, for the same client, few of the reports were taking more than 4 hours to generate. And even in the use case section, I am having few interesting use cases. One from CS Holding. We'll discuss that. No scalability, guys. This is one of the very big issue, because we are aware that with time our requirements will change. With time my business will grow. With time my user base will grow. With time my data will grow. My repository, my conventional technologies, my RDBMS should also scale to handle my requirements. But you can't scale because it is deployed on single machine. At max what you can do, you can add more hardware, you can use big systems, but how much big system you can use? One of very big issue. Single point of failure. Guys, take the example of most popular RDBMS, Oracle, deployed just on single machine. If that machine is powered off, there was some power issue, some issue is there, so you don't have any options. Although some costly solutions are available, that's also very rare, but in usual cases it is single point of failure. Sequential processing. On a single machine, you can't have true parallel processing. On a single machine, you can't have true parallel processing. Another issue, RDBMS can handle unstructured data. Guys, what about RDBMS can handle structured data. RDBMS can't handle unstructured data. What about the 80% data that is unstructured? RDBMS can't handle that data. RDBMS requires pre-processing of the data. You can't store your raw data as it is. According to data scientists, data is in its richest form when it is raw. But with RDBMS, you need to use ETL methodologies. You need to transform your data before loading inside repositories, before loading inside your warehouse. So you need to pre-process your data. That is not acceptable by the data scientists. That is not acceptable in today's industry. So guys, I have discussed certain issues with the conventional approaches. If you talk about the another conventional approaches like mainframes, that is also facing tons of issues are there. We all are aware. And that's why people are running mainframe elimination project. CS Holding is running, Infi is running mainframe elimination project. So mainframe, which is very costly, is now being replaced by big data systems. And even it is anticipated that by the end of 2017, 70%, more than 70% of mainframe systems will be eliminated and will be deployed on big data. If we talk about conventional distributed systems also, like SAN, storage area network, there are tons of challenges like data transportation issue. My data is transported, my data travels there a lot, again and again. But if I am having data in the range of petabytes, I can't really move my data. Partial failure is very difficult to handle in legacy systems. So guys, overall if I conclude about my legacy systems, there are tons of issues, challenges that currently industry is facing because of high volume, high velocity and high variety of information, high variety of data. These technologies were very good for limited volumes, for low velocity and for structured data. So guys, the question is, what is the solution? Now what is the solution? The solution is big data Hadoop. Guys, big data and Hadoop are like synonymous to each other today. Although Hadoop is the solution of big data problem, but due to power, due to popularity, and there is no competitor of Hadoop in the industry. That's why Hadoop is most popular. That's why Hadoop is most powerful. Hadoop is the only solution in the industry for the big data. Let's understand what exactly is Hadoop. Introduction to Hadoop. Guys, Hadoop is an open source project. Hadoop is an open source project from Apache Software Foundation. Now you'll ask me, oh, it's merely an open source project, but industry don't accept open source projects. Guys, the answer is Hadoop is the first project that has been accepted by all the industries. Even Microsoft has done the partnership with Yahoo to make Hadoop compatible with Windows. Microsoft, the biggest provider of proprietary software, is also running behind big data Hadoop. So, but still guys, if you are worrying that I can't work, your company can't work on open source, don't worry. Hadoop is available in proprietary versions as well, from IBM, from MapR, from EMC's Pivotal, from Cloudera also. So you can purchase it from there, but its open source nature opens the door for the researchers, developers, scientists for research. Like if I share my own case, when I was working with a leading retailer, certain functionality of Hadoop was not fulfilling my requirements. What we did, guys, we simply downloaded the source code, we changed that according to our requirements, and we simply deployed that. That's the beauty of open source solutions. Hadoop provides a software framework. Guys, it is a complete end-to-end framework for distributing and running applications on cluster of servers. Can anyone tell me what is cluster? Cluster of servers. What is cluster? Correct. Multiple machines connected together. Good. So guys, multiple nodes, multiple machines, multiple servers connected together is called cluster. So Hadoop is a framework that distribute your application across cluster, across multiple machines. Guys, Hadoop works on multiple machines distributedly, and it distributes your work to all the machines. So a little bit history about Hadoop. It is actually inspired by Google's MapReduce programming model and Google file system. And guys, we are aware Google is the mother of all the invention. So when Duck Cutting and his team was working on Nutch search engine at Apache, they got some requirement of distributed processing framework, distributed storage framework. So they saw a paper from Google that Google told that these technologies they were using from early 2000s. So they started Hadoop as a sub project. Guys, Hadoop was merely a sub project of Nutch, but soon due to the popularity, soon due to the power, Hadoop became the top level project. Guys, Hadoop came into limelight in 2008 when it was not even in alpha. It was in development in early stage only. At that time, Hadoop defeated supercomputer in Terasort. Hadoop defeated supercomputer in Terasort and it came into the limelight. At that time, guys, the big giants like IBM, like Yahoo, Facebook, Cloudera, they saw much huge potential in Hadoop. And although Hadoop is open source, but it is developed by industry's top-notch talent. More than 90% of Hadoop code came from companies like Facebook, Yahoo, IBM, Cloudera. So guys, Hadoop, an open source framework that is written in Java. Hadoop is completely written in Java. So now there is always a question to learn Hadoop. Do I need Java knowledge? I would say yes and no, both. If you want to become Hadoop developer, surely you will be needing knowledge of programming language. But if you want to become like an admin, architect, or for different positions, Java knowledge is not mandatory. Even Hadoop provides you the mechanism to code in other languages also, like C, C++, Perl, Python, Ruby, Groovy, etc. But although guys, people are suggesting, people are saying that you can code in Perl, you can code in Python, you can code in any language. But my personal suggestion, you should code in Java. If you are planning to become a successful Hadoop developer, you should code in Java. Why? Because guys, the top level APIs are not that much developed, and if you code in Java, you will be having lower level control. You will be having lower level control, and you can do whatever is your business requirement. You won't be having any issues. You won't be having any shortcomings. My own personal experience, when we were coding in other language, once we were coding in Perl, and after developing 45% of the code, there was no path ahead. That's why for the developer, Java is required. In the ecosystem, guys, we'll see that there are various fronts in Hadoop. For SQL lovers also there is one front. For script lover there is one front. For NoSQL database there is one front. So you can use according to your own interest. Hadoop efficiently process large volumes of data on a cluster of commodity hardware. Can anyone tell me what is commodity hardware? I'm sure guys now many of you have heard about this term, commodity hardware. Correct, cheap machines, low end machines, low cost machines, like your i5 machines, merely 4-core machines. Guys, Hadoop has been deployed by many orgs on merely commodity hardware, and Hadoop can process volumes, data in the range of terabytes, petabytes on the commodity hardware. Hadoop is very economic, and when I was discussing with the director of Yahoo, I came to know Yahoo has deployed 54,000 machines. 54,000 machines, its first set of clusters, just as a commodity hardware. So guys, you will be surprised to hear that, yeah, there are 54,000 machines. By the way, this is almost 1.5 year old news. Now it's more than 54,000 machines that is running at Yahoo. So guys, till now, again and again I am saying that Hadoop doesn't work on single machine. Hadoop works on cluster. Multiple machines are there which works parallelly. So for my learning, do I need multiple machines? Answer is no. Hadoop can be set up on single machine. Hadoop can be set up on single machine for your learning, for your R&D, for your testing, development, all such purpose. For all such purpose, you can deploy Hadoop on single machine. But for the production, you must need a cluster, because real power of Hadoop comes in a cluster. Guys, another interesting fact, Hadoop can be scaled from single machine to thousands of nodes on the fly. Very important point. Without any downtime, you can scale your cluster. Today you are having 50 node cluster. Tomorrow requirement increases, no issues, add 10 more machines. Now you are having 60 node clusters. Hadoop consists of three key parts. HDFS, the storage layer. Hadoop, distributed file system, the storage layer. MapReduce, the processing layer. Yarn, the resource management layer. So guys, we'll discuss in this section HDFS and MapReduce. Yarn we'll discuss in actual sessions. So before that guys, let's answer a question. Why Hadoop? Let's answer a question. Why Hadoop? Apache Hadoop, a platform for data storage as well as processing, is highly scalable. The answer is Hadoop is highly scalable. We can scale it to nth level. Guys, do you know the biggest size of cluster that has been tested is 15,000 machines just in a cluster. It means when you submit your work is done parallelly by 15,000 servers. You can imagine the speed. You can imagine the performance. Hadoop is highly fault tolerant. Failure of machine doesn't affect Hadoop. If your machines are failed, no issues. Hadoop is intelligent enough to handle all the failures. It is open source. It's free of cost. No need to purchase license, and even the source code is also open. So before discussing other characteristics, let's talk about core components of Hadoop. HDFS, that is distributed storage and data protection layer across the cluster. It provides distributed storage. MapReduce, it provides distributed computing layer, distributed computing across the cluster. And Yarn, it is a resource management layer which provides you resource management, end-to-end resource management across the cluster. So guys, few more characteristics. Hadoop has the flexibility to store and mine any type of data. You can ask the questions across structured to unstructured data that were previously impossible to ask. It is not bounded by a single schema. You don't need to even create a schema. Guys, we are aware that in Oracle, if you want to store the data, firstly you need to create a schema. But in Hadoop, its storage layer is just a file system where you can create a directory and store any type of data. You are getting the data in video format, no issues, Hadoop will happily accept. You are getting the data in the XML format, no issues, Hadoop will happily accept. You are getting the data in the form of machine data, binary data, Hadoop will happily accept. Hadoop excels at processing complex data. It excels at processing complex data. Its scale-out architecture divides workloads across multiple nodes. Its flexible file system eliminates ETL bottlenecks. You don't need to pre-process your data. You don't need ETL methodologies. You can directly extract and load your data. Rather than ETL, there is new term that is coined in, that is ELT. We will discuss ELT in great details in actual sessions. scales economically. Guys, Hadoop can be deployed on commodity hardware, no need of expensive hardwares, and its open source nature platform guards against vendor lock. No need to stay with a vendor whom you don't like. If you don't like the services, you can simply change the vendor, because you haven't purchased Hadoop. You have simply downloaded free version. Hadoop is free. Hadoop is free of cost, open source. Now guys, let's understand Hadoop architecture, its basic architecture, how exactly Hadoop looks like from a height of 50,000 feet, from a quite big height. Hadoop is having master as well as slaves. Guys, Hadoop works in master slave fashion. Hadoop works in master slave fashion. So as the name suggests, master doesn't do work. Master assign work to the slaves. Master take work from the slaves. Master is like a coordinator, manager. So guys, if user want to perform any work, he will submit that work on the master. Now master will divide that work and submit to all the slaves. Guys, look at it. All the slaves are doing sub work. So guys, suppose if we are having 100 slaves, so surely as compared to Oracle, our performance would be at least 100 times faster. The performance will be at least 100 times faster. So guys, if I give you one analogy, one person building a home is a case of Oracle, and 100 persons building a home, case of Hadoop. Surely it is at least 100 times faster. So guys, in this particular case, 100th work will be done by each and every slave. 100th work will be done by each and every slave. Master doesn't do any work. Master's work is for the coordination. Now you'll ask me, what about multiple masters? Guys, if one master is down, the standby master will automatically take over. And even failure of slaves are also doesn't affect Hadoop. It doesn't make your system down. Hadoop is pretty much intelligent. But how? This question we can't discuss right now, as due to limitation of time. We'll discuss the same in actual session. Let's proceed ahead. Introduction to HDFS. Guys, the very first component of Hadoop, that is HDFS, the storage layer of Hadoop. It is a distributed file system that is designed to run on commodity hardware. It is merely a file system. At the core, it is a file system that is distributed, that is highly fault tolerant. My HDFS is highly fault tolerant. By the way, guys, HDFS is accepted as world's most reliable storage system. HDFS is world's most reliable storage system, and by the end of 2016, it is anticipated that more than 75% of the data of the planet will be stored inside HDFS. So guys, HDFS highly fault tolerant. What do I mean by fault tolerant? failure of machine doesn't affect HDFS. You will not lose your data. It's distributed. So guys, if I highlight its main features, fault tolerant, distributed, your data will be distributedly stored. It's reliable. There is no issue of data loss. There is no issue of data loss. It's scalable. So on the fly guys, we can add more machines. So adding of machine surely will scale your storage as well as processing. So guys, HDFS developed to handle huge volumes of data. HDFS is developed to handle huge volumes of data. That is data in the range of terabytes to petabytes, large file size, single file of size GBs to TBs. Now guys, the second part of this slide, that is storage mechanism. It is a little interesting. Let's discuss it. How exactly your data is stored in HDFS. Suppose you are having a file, big file. So firstly, your file will be divided. Your file will be split up into blocks. Your file will be divided into smaller chunks or blocks of merely 64 MB. And then these blocks will be stored distributedly across the complete cluster. Even guys, Hadoop stores multiple copies of the blocks on different nodes. Let's understand the same thing via some animation. Let's understand the complete storage mechanism via an animation. So guys, on the right hand side, you are having a Hadoop cluster, what architecture we have seen. And left hand side, we are having a large file. Now, you want to store this file in HDFS. So guys, how the file will be stored in HDFS? Firstly, the file will be divided into smaller pieces. The file will be stored into smaller pieces called blocks of merely 64 or 128 MB. So guys, you can understand for 100 terabyte file size, number of blocks would be thousands. I am showing you for only 4 blocks just for simplicity. So guys, now these 4 blocks will be stored distributedly across the cluster. Across my cluster, these blocks will be stored distributedly. Look at this. Block 1, B1 is available on this node. B2 on some other node. B3 on some other slave. B4 on some other slave. All these data blocks are stored distributedly. Now guys, one question, surely a logical question that you will surely ask. I told failure of machine doesn't affect Hadoop. I told failure of machine doesn't affect Hadoop. Now the question is, block 1 is stored on suppose slave 1 and slave 1 is down. Suppose slave 1 is down, slave 1 is failed. Hard disk crashes, power issues, network down, some issues is there. Now what will happen to my this file that is 100 terabyte in size and just one block is missing, one machine is missing, one machine is down, so one block is missing. One block or few blocks are there. Then guys, Hadoop stores multiple copies of data. Hadoop stores multiple copies of data. That is, block 1 is available at by default 3 locations. Look at this. Block 1 is available here as well as here. Apart from the failed machine, block 1 is having 2 more copies. Hadoop stores 3 copies by default. Even you can increase or decrease the same. You can change this replication factor. But guys, Hadoop is highly fault tolerant. Failure of machine is taken care automatically. If machine is down, my master will come to know immediately. Master stores metadata. Master is having all the informations about all the slaves, all the blocks, all the files, metadata. And if one slave is down, no issues, master knows where the same blocks are available, where the replicas are available, and it will redirect the request. It will give you the data from those slaves. It will redirect your request. So guys, that's very basic about HDFS. Now let's proceed ahead for the MapReduce. Now MapReduce will cover just a very basic. So MapReduce is a programming model. It's merely a framework, a model that is designed for data processing. It is designed for processing large volumes of data in the range of terabytes, petabytes, thousands of petabytes. It processes the data in parallel. Guys, MapReduce processes the data in parallel. How? It divides the work into set of independent tasks. Your work is divided into independent tasks and it will be done distributedly. So in next slide, I'll again explain this definition with an animation. So usually guys, what happens that with the animation, we can visualize the things. So usually I try to incorporate as much as animations for the data flows and other things. So you can really imagine how exactly things are flowing end to end. That enhances your learnings. MapReduce is the heart of Hadoop. It moves computation close to the data. Guys, instead of moving the data, MapReduce focuses on movement of algorithm. It moves algorithm to the location where the data is available. So guys, this programming paradigm allows for massive scalability across thousands or even hundreds or thousands of clusters, servers in the clusters. So if guys we understand, if we want to understand MapReduce, on the right hand side we have the Hadoop cluster with the data stored. Block B1, B2, B3, B4 are available here. The same cluster what we have seen. So we have already stored the data here. Now user come here and user want to process this data. To process the data, you must have to develop MapReduce algorithm, MapReduce code. So guys, user has developed a MapReduce code, MapReduce job. User need to interact with the master. User have to submit the MapReduce job, his work, his code on the master. User submits his code, his algorithm on the master. Now guys, look at the beauty. Master creates several copies of this particular code and it sends the copies to all the slaves wherever the data is available. Like one copy of slave came here to process block B1. Another copy came here to process this block. Instead of moving the data, MapReduce code moved code of hardly size few KBs. This particular code traveled from master to all the slaves wherever the data is available, and it will process the data that is available on this machine. Like this MapReduce code, that is if I highlight, if I mark a tick mark here, this MapReduce code will process block B1. The code traveled to the third machine will process block B2 and so on. So guys, in this manner your data will be processed distributedly on multiple machines. So guys, you can understand Why Hadoop is that much fast, lightning fast. So guys, that's very basic about MapReduce. In the actual session, we'll spend quite long time in MapReduce. Let's proceed ahead. So let's quickly see the Hadoop ecosystem. We already talked about HDFS. HDFS, the storage layer of Hadoop. What about next? It's MapReduce. MapReduce, the processing layer of Hadoop. MapReduce is the processing layer of Hadoop. So guys, for the developers, they need to write code in MapReduce. They need to develop the code in MapReduce. Now, in between of HDFS and MapReduce, we have a resource management layer. We have a resource management layer, that is YARN. Resource management layer, that is YARN, that manages all the resources of the cluster. YARN has been introduced in the latest version of Hadoop. In the older version, YARN was not available. So guys, you can submit multiple types of application on the top of YARN, like MapReduce, like Spark, like a number of different applications you can submit on the YARN. Now, for the top level components, like if you want to submit SQL query, you have Hive. We have Hive available here. So we can submit merely SQL queries in Hive, and Hive will convert that query into MapReduce job automatically. And now guys, if you are from scripting background, so you are having knowledge of scripts, you can develop scripts. You can submit your scripts in Pig. So you can develop the script in Pig Latin and you can submit the scripts, and Pig will convert that script into MapReduce job. Now guys, for the data collection, we have two tools, that is Scoop and Flume. For data collection, we have Scoop and Flume. Scoop, that is an acronym for SQL to Hadoop. So we can collect the data from RDBMS and vice versa using Scoop. On the other hand, Flume is a general purpose data collection system. We can collect the data from n number of different sources, and we can even write the data to n number of different destination using Flume. So these two tools are for the data collection. Now, since we have multiple tools, multiple components in the ecosystem, we have Oozie. Oozie is available for workflow. We can create end-to-end workflows in Oozie. We can develop our workflow in Oozie. And guys, apart from this, we have one more component, that is a NoSQL database, HBase. Guys, HBase is a NoSQL database which can handle data in the range of thousands of petabytes, and it will give you response in the range of sub-seconds. In the range of sub-seconds merely, it will give you response. So guys, this is overall Hadoop ecosystem. During our training, we will cover complete ecosystem, all the components. Let's proceed ahead. So guys, next section is big data use cases. Credit card fraud detection. Guys, let's understand firstly the problem statement. Although we have already talked about this, US National Bank, which has a revenue of $10 billion, is losing about 2% of its revenue, that is $20 million, due to fraudulent card transactions. So guys, the objective is to identify whether the requested transaction is fraudulent or not. To identify the fraud in a transaction is very challenging, as time needed is very less, merely few seconds or few milliseconds, and volumes are very high, velocity is very high. So guys, I think we have already discussed credit card fraud detection in great details. Just one more line. So we need to process the data in real time. That is data in motion analytics. We need to do data in motion analytics. We don't have much time. So guys, like we don't have that much time that we can store the data and then process. No, then we will be out of the picture. We need to process the data in real time in these streams. Like you can understand, like you can easily imagine the water stream, how exactly water flow. Similar to that, your data flow. So guys, you need to process that data while it is flowing, while data is in motion. You can't wait till it is stored, indexed, and all. Let's discuss one more use case, that is sentiment analysis. Sentiment analysis. So guys, here the objective is to identify the orientation of opinion in a piece of text. We want to analyze users' feeling, what exactly people are thinking, what exactly people are saying, whether they are saying positive or negative about me. So guys, the sources may be blogs, user comments, user review websites, community websites, news websites, social media sites. So here, sentiment analysis provides substance behind the social data. And guys, today every consumer facing industry, every customer facing industry is interested in finding about, in knowing what their customers think about them, whether they say positive or negative about them. So that's how they can create a brand value. Like Apple is having quite big brand value. Everybody means having most of the satisfied customers, Apple. But say if you are launching a new product, you can find out users' feeling, users' opinion about that product also. But before that, one more point. Sentiment analysis processes the language. It understands consumer feeling and attitude towards a brand, towards a topic in online conversation. So guys, it's like, say I am the owner of Microsoft and I want to know what is people's opinion about me, what people think about me. So I can collect the data from all the websites, all the user review sites, social media sites, and I can find out, okay, whether they are satisfied or not. Apart from this, apart from the brand value, apart from knowing your customers, there is another, by the way, sentiment analysis is most popular use case in the industry. Today, every customer facing industry is doing this project. And even with my previous org, my team has deployed this project to many clients. Let's talk about one more use case. If a company is launching a new product, suppose you are an owner, you are a owner of a company and you are launching a product. Now, once you launch a product, you want to find out whether people are liking it or not. You want to find out whether it is a successful or not, whether this particular product is successful or failure. How you can come to know about that? If I don't talk about sentiment analysis, if I talk about our conventional way. So guys, earlier we came to know the success or failure of a product from sales reports. So like usually sales report take 4 to 6 months to be finalized, to be ready from across the globes, from which we can draw the results. Like 1 day or 1 month sales report, we can't draw the results. So because now we are launching the products across the globe, US, UK, China, India, everywhere. So it takes quite long time. But guys, just imagine you have developed a product, you have launched it, and now after 4 months you will come to know whether it is a successful or not. But what will happen in this 4 months? Your production is continuing. You are continuously developing new pieces, new units. If it is a failure, if people are not liking it, guys, understand, there will be a big loss. Say you after 4 months you came to know people are not liking it. It will be very big loss for you. Rather than that, if you launch a product today and use sentiment analysis, start collecting the data from all these sources. Now guys, on the same day we can draw the result. We can come to know whether people are liking it or not liking. So for several of our clients, we have showcased this demo. Like today they have launched the product, and today end of the day we came to know about the result. Like for one of the client, what happened that 70%, more than 70% of the people were saying negative about their product. Main feature was missing, there was some bug. They immediately stopped the production. It was one of the very big project from very big that our client appreciated us. So actually on the same day they stopped the production, it saved their millions of dollars, and they improved their product based on users review, and they launched a upgraded version. So guys, sentiment analysis enables business to make early decisions rather than wait for sales reports. Very nice project. By the way, this particular project we will be having in our practical also, like as one of the real life project. Let's proceed ahead. Retail data processing. So guys, this is a real case study from one of my client. My client is getting 100 GB of invoice data daily in the XML format. We are aware the data is in the XML format. So guys, although 100 GB is not quite huge, now the requirement is this invoice data needs to be transformed into structured format, which involves very complex validation, very complex verification, and business rule implementation. The problem is legacy systems are not capable of processing data in optimum time period. Guys, when we visited them, their conventional approach was in Perl, using which they were doing the parsing, and time taken by them to process their data was 10 hours. And we got a requirement if we can reduce this time to 50%. If we can reduce this time to 50%, that is instead of 10 hours, if we can make it to 5 hours. Guys, we developed our solution in big data. We developed in Hadoop, pure MapReduce. We were very surprised. With our client were also surprised. The time taken, our big data solution was capable to process the data in merely 10 minutes. We have reduced time from 10 hours to 10 minutes. That's the beauty of big data. By the way, I was personally working on this project, so we got several accounts open after this particular project from our client. So this is really the very big surprise for us also. It's now quite more than 3 years old story. I'm having one more interesting use case. Let's proceed. Let's talk about that. Sears Holding case. So guys, Sears Holding is using Hadoop to personalize their marketing and loyalty campaigns. Sears has 4,000 stores with millions of products and 100 million customers. They have collected 2 petabytes of data so far. they have collected 2 petabytes of data so far. So guys, the problem is their legacy systems are incapable of analyzing their large amounts of data to personalize marketing and loyalty campaigns. Their conventional approach, they have analyzed just 10% of their customer data for personalizing loyalty and marketing campaigns on mainframe, Teradata and SAS. On mainframe, Teradata and SAS, guys, these technologies, they were able to analyze their 10% of data. Guys, processing time for 10% of data is, guys, look at this, processing time of 10% of the data is 6 weeks. 6 weeks. They have shifted to big data. They have shifted to 300 nodes of commodity servers. They have shifted to 300 nodes of commodity servers. Now guys, look at the beauty. Time taken to process 100% of customers' data is now merely 1 week, from 10% 6 weeks to 100% 1 week. Interactive reports can be developed in 3 days instead of 6 to 12 weeks. They have saved millions of dollars in mainframe and RDBMS cost and got 5,000% better performance. It increased their revenues through better analysis of customers' data. So guys, by the way, this is a case study that has been opened by Sears. This particular case study is available on Google as well. So that's quite a nice case study. That's the beauty of big data. Let's proceed ahead. Now guys, let's talk about other big data use cases. Just quickly, I'll take it. There are tons of use cases in IT infrastructure optimizations, advertising analysis. Like if I just discuss this, I'll take 30 seconds for this. Earlier the advertisement was broadcasting. We were showing advertisement to all, but today it is unicast. Like today if we are searching on Google about apparels, about mobile phone, about laptop, Google will show us relevant advertisement. For user A, the advertisement is different. For user B, the advertisement is different. For user C, advertisement is different. Guys, for each and every user, the advertisement is different. So it's now highly content driven. Advertisement is shown only to the intended audience. Like in the Google, we get immediately the advertisement. If I am searching for a mobile phone, I'll get the advertisement from Flipkart, eBay, Amazon, etc. Predictive analysis to give the predictive reports, what will happen. Customer churn analysis, biggest issue of customer facing industry, why people are leaving me, tons of use cases in customer churn. Aadhaar project by Government of India, all your unstructured data is stored in Hadoop, big data, like your retina scans, your fingerprint scan. Weather forecasting, we already took one use case of Hudhud. Healthcare analysis, we'll take guys each and every use case in actual session. Natural resource exploration and so on. Let's proceed ahead. So guys, that's it about big data use cases. Now let's talk about future and careers in big data. Guys, it is not a secret that big data is now in the agenda of all the Fortune 500 companies. Everybody is running behind big data. So guys, if we talk about compound annual growth rate, this is a nice infographic from Xperfy. Hadoop market will reach $50 billion by 2020 with a compound annual growth rate of 58.2%. That's really huge, 58.2%. So guys, if we categorize the market by the market type, application software, package software, performance monitoring software, management software, etc. If we categorize by service type, consulting services, Hadoop test training and outsourcing services, integration and deployment services, middleware and support services, and so on. By hardware, it's a storage, servers market, network and equipment market. By the end user, it's manufacturing, BFSI, retail, telecommunication, healthcare, government sector, media, entertainment, trade, transport, and so on. Tons. Almost every user, every end user, almost every company, every domain is using the same. Let's proceed ahead. So guys, IDC forecast suggests that the big data, technology and service market will grow at 40% a year, which is 7 times the estimated growth rate of overall IT and communication business. That's really huge. Another research suggests that by 2016, more than 75% of the data on the planet will be residing in Hadoop. Let's proceed ahead. So guys, even I'm sure all of you are aware about the future of Hadoop, about the future of big data. It's not at all now secret. Everybody is now running behind big data. So CIO Insights, a leading magazine, big data is big time important to the enterprise. A whooping 80% of companies say big data is important to their ongoing business operations, with 43% saying it is mission critical. Guys, why it is mission critical? Due to the shortage of big data talent. That's why guys, DataFlair comes into the picture. We bridge the gap between the industry requirements and talent available. We provide you the exact practical skills which employer need rather than theoretical knowledge. All the instructors are more than 15 years of experience, and even big data batches I am taking personally. So guys, we mostly deal in the practicals, we mostly deal in the workshops. With each and every small concept, we will give you one workshop. We will assign you lots of assignments, practicals, and we'll show one workshop, one practical from our side also, which will enhance your learning. We show several animations, several use cases, several images, several architectures, several flow diagrams, with the help of which you can imagine, you can understand end-to-end data flow. Let's proceed ahead. So guys, another big data prediction. So our digital universe will be of 40 zettabytes by 2020. The US has 1/3 of world's data. Big data is one of 5 US GDP game changer. 65% analytics app with Hadoop inside by 2015. 50 times the data growth from 2010 to 2020. 15 times growth rate of machine generated data by 2020. And so on. There are tons of insights available here. As we are running out of time, let me proceed ahead. So guys, Google Trends. Just on Google Trends, even you yourself can type this. Look at the graph, red and blue, of Hadoop and big data. It is growing. It is going up, up and up. It is continuously going up. It is even exponentially going up. And other technologies, even ETL, data warehousing, they are going down, green and yellow. They are going down, down and down. Google tells everything. Google knows everything. So that simply shows you the requirements, simply shows you the trend. If we proceed ahead, so guys, companies using Hadoop, so I can't really list out all the companies. There are tons of companies, almost all the companies are using Hadoop, frankly speaking. IT companies like Infosys, Accenture, IBM, TCS, Wipro, Cognizant, HCL, EMC, Dell. Analytics outsources, Mu Sigma, Fractal, Absolute Data, LatentView, Genpact, WNS, and so on. Retailers, Reliance, Walmart, Sears, Tesco, Carrefour, and so on. Consultants, PwC, KPMG, Deloitte, McKinsey, Capgemini, CSC, Gauss, and so on. It's an unending list, by the way, so I have listed just a few big names. If I talk domain wise, financial domain, Citibank, SBI, HSBC, ICICI, JP Morgan, Barclay, Amex, sorry. Telecom domain, Airtel, Reliance, Vodafone, Idea, TTSL, and so on. Healthcare, Novartis, Dr. Reddy's, Ranbaxy, Cipla. E-commerce, Amazon, PayPal, Flipkart, Snapdeals, eBay, Alibaba. So guys, it's like everybody is using. So if we talk about careers in Hadoop, so guys, there are now tons of job roles are available from the freshers, a junior developer, to the directors, to the director level. So just 4 roles I have highlighted here from the perspective of job function. Architect, who provides end-to-end solution, end-to-end business solution, who design, manage, and provide end-to-end solution. Skills required are HDFS, MapReduce, Hive, all the ecosystem components are required, and experience level is more than 10 to 12 years, at least 12 years. Little junior roles like developer. So guys, developer develop the MapReduce jobs, and he must be the master of MapReduce, HDFS, and Hive. So highlighted skills, he must be a master, and experience level is 0 to 5 years. By the way, other skills, he must have basic knowledge like HBase, Pegoose, he must have basic knowledge of others. Developer actually develop the code. Admin install, admin deploy the cluster, admin set up the cluster, admin monitors it, admins maintains the cluster, and he must have knowledge of Hadoop, Linux, network management, hardware skills. Again, the experience level is 0 to 5 years. Another job role, it's a little interesting, that is Hadoop Analyst, who analyzes large amount of data and brings out the insights. He merely should have the knowledge of Hive and SQL mainly. And experience level is between 0 to 5 years. Apart from that, guys, there are tons of roles like Hadoop managers, Hadoop lead, big data lead, big data even in the pre-sales, sales, Hadoop architect, big data director of engineering, and so on. Almost all the at all the levels we need Hadoop and big data, guys. So guys, just one more slide for the job trend from the Indeed.com. Look at the Hadoop job trend that is going up from 2009. It started going up and still going up and up. I think we shouldn't discuss more. It's the booming. It's the future. It's the future. So guys, just a little bit thing about us, about DataFlair. Why choose us? We are having trainers who are having more than 16 years of professional experience, more than 5 years of training experience. The training is very interactive, guys. It's the guarantee that the training will be very interactive. You will be having the feel of classroom. There will be complete environment of classroom learning while you can be at home. Since this is online, you can attend from any location. So as we don't take more than 10 guys in a batch, there will be individual attention. People take more than 30 guys in a batch, but we don't take more than 10 guys. So there must be one-to-one communication. We mostly concentrate, guys, on practical session. This is the difference between the other players and us. We usually focus on practicals, and we don't have any freelancers with us. I don't have any freelancer with me. All the guys are working, whoever is taking the training, they are working, they are at the senior post in some companies. So theoretical knowledge, guys, I'm sure you can read the book and you can gain. So that's why we mostly focus on practical. Guys, another interesting thing, we record all the sessions and you will be providing the recordings of the session, and you will be having lifetime access of all the recorded sessions. Lifetime access will be there. You can get assistance in resume and interview preparation, interview questions. I usually keep giving lots of interview questions with these sessions. Regular study materials, assignments, workshops helps in battling. Even you will be given all the codes also, like practical code, you will be given POC code also. Every code will also be available in the LMS. You will be having discussion forum, and on completion of the course you will get a certificate from DataFlair. And this course surely will prepare you for the cloud data certification, that is the leading certification in the industry. Even we will be dealing far above the level of certification. So guys, the main objective of this course, the end result of this course is to become employable in big data and Hadoop industry. So you can gain the practical skills which employer need rather than theoretical knowledge. Here you will be working on POCs and live project, which you can surely update in your CVs as well. You can get the job assistance from our side. So guys, that's it from my end. Thank you so much. Now the platform is again open for the questions.